Choose one.
Jumping right back into it. Okay, I'm already still here. Why do we bind the 3 players? Okay, why do we bind the 3 sheets before joining into the division data? And the rationale behind that is because if we don't do it like that, we will waste code or waste space in terms of joining each player with the division data, where that's not necessary. So it's imperative that we bind all the data that's going to be eventually joined to the division data, and that's a nice practice in terms of workflows with real data. So binding first creates one consistent player. Let me try this. Data frame. We'll see if you can still hear me after that. But data frame. Which is cool. So then from there, what we're going to look at is, before we really do the join with the division, there's some things to, I guess, reiterate, okay, that I just mentioned, but then at the same time, bring to your attention. So again, the player data lives in the player data frame, and the division data lives in the division data frame, and so we need to join them in some way, shape, or form. And based off of the situation, we would want to implement one, either the left join, right join, full join, or inner join. Okay, one of those, because we're going to be merging the data. Sorry, I heard merging the data in some way, shape, or form. Whereas the anti-join and semi-join are used to filter in some way, shape, or form. We're going to use the anti-join to do some confirmation, but the idea is for us to be able to join the data frame utilizing the left join. And the full join would work as well. Okay. So here, I did the work for you because we're going to do some other heavy lifting. But here you're seeing that we're taking the division data frame. Okay, well, let's go ahead and just run this and see what our data actually looks like in terms of the division data. Oh, that makes sense. It should be an underscore LST. Okay. Okay. And then copy and paste. Put this here. Boop. And then let's look at division data frame. So when we look at the division data frame, some things in terms of understanding when working with variables, ideally you should have a similar format, whether it's camel case or it's underscores between spaces and underscores instead of spaces. And so there's a lot of different ways of actually specifying the variable names. But here is we're gonna clean some of these up and so that they have better column names. So this is what we do, right? We're gonna rename these variables. So that's that. So when I do that, you can see that the variable names are now more digestible, easier to read, okay, and more consistent. All right. So now that we did that, let's do a check. We want to do a check with the anti-join so that we can make sure that each team, I think LeBron James' Cavaliers, Kobe Bryant's Lakers, and Michael Jordan's Chicago Bulls, that those teams appear in the actual divisions data frame. Okay, we're going to make sure that's the case. And we're going to do that by utilizing the anti-join, okay? By utilizing the anti-join. But watch how we do this. So we're going to look at NBA underscore DF underscore players df. Okay, run this. Okay, you can see the data frame. Okay, 3400. We're going to pipe this into distinct. Okay, distinct is going to provide the columns. The variable based on team, based off of what's distinct in terms of the players. So when I run this, it only should be 3 rows. Let's see. So we technically have data on when LeBron James played for Miami, which is fine, okay? But again, the idea is that we're going to check to see that it is within the division data frame, okay? So that's that. So we're going to now take this and do a pipe and do an anti-join to see if there's any matches in non-matches in the second data frame. So we're going to take anti-join of division, df, comma, but this is new, by C. So the left data frame terminology for team, right, is going to be TM. Okay, it's TM, right? So we say TM. But then on the right for divisions, it's team. All right, and so that's where we just say equals team. And so if there's a mismatch, right, if there's a variable that exists, if there's a team that exists in the left that doesn't exist on the right, we're going to now see that as an output. Okay, we're going to see that as output. That's the idea behind filter. What happens in the left that's not in the right? Okay, and so when I run this, if there's a mismatch, it's going to appear. If it's not a mismatch, that means that every single row in the left appears in the right. That's why it's 0 by 0. It does match. Okay, so these kind of checks, we don't have the time to do each and every kind of check that's possible, but these kind of checks allow us to be a little bit more responsible with our data, with understanding what's going on with our data. Okay, so at least being familiar with that is nice. Okay, so why do we run this anti-join before the real join? Let's answer this. So the idea is that this checks whether any team abbreviations in the player data are missing from the division lookup table, or look up the division data frame. So I don't have to type. So you can see why we would need to do this kind of checks. Okay, so that's nice. So now that we did the check and we're good to go there, we can finally do the join. Now we can finally do the join of players. So what we can do is do NBA players. Okay. Pipe this into the left join. I should have asked what join it should be, but it's going to be to the left. And then we're going to do it by, do it to the divisions data frame. But then by what we did earlier in terms of the team. So we're going to do, because to the left is TM, capital T. And then to the right is just lowercase team. Okay. And run this. Okay. So now instead of having 3400 by 40, it's 3400 by 43, which contains the conference, the division, and team name. Okay. And the team name. So what we're going to do is save this as NBA. I mean, this is not the greatest name, but NBA join DF, and then assign it. Boom. We got the data. Okay. We got the data. So if we just run this and then look at it again, I like to do this. See all the variables. Okay, all the variables. And then the distribution. Oh, this is so cool. Positron can make me cry. It's amazing what you can do with this. All right, so that's cool. That's cool. So we have it joined and everything, and that's pretty nice. Why does by team tell left join? What does? Essentially, it says it tells left join that matching key has different names in the two data frames. It allows you to then join based on those column names from the left and to the right. Okay. So that's pretty cool. It's pretty nifty. This one is just cleaning up some things. So again, we're using a mutate variable, okay, mutate function, okay, and so we're making it just a little bit more cleanly for our analysis. So the very first thing that we're going to do is extract the number, okay, from season. If you remember, that's from string R, okay, which is going to be string extract, okay, and then once we extract that number using that / I always get that messed up, twice D plus, it allows us to specify a number. We would now then turn that into an integer as that integer. Okay, so that's that. In the ETV cycle, I don't remember doing the if else function, but the if else function allows us, if it's a binary option, to specify the outcome. So if game outcomes equal to W, it means win. Game outcomes equal to not equal to W, it means loss. So that's that. And then we're just changing the name here. So instead of game location, it's very ambiguous. It could be Orlando, Florida, or it could be home. So it's better for us to specify that game location really means home or away. Last but not least, we're going to classify points as groups, okay? And in order for us to do that, in order for us to reclassify, a quantitative variable is to use case 1. And then last but not least, since we're dealing with these groups, it's better, in order for us to specify the order under 20 to 30, 29, so on and so forth, we have to turn this into a factor so that we can actually specify the order, okay? So that's that. So when we run this, we can actually see some of the data frame, see that it makes sense. NBA analysis DF looks pretty good to me in terms of the players and things in that regard. Okay. Let's see, what does it say? It says, why is it useful to create season number outcome points underscore groups before plotting? These columns translate into new or raw workbook fields, or allows us to have better names for our columns and to do analyses. These columns allows us to have better names for analyzing the data using visualizations. And so the thing is, even with that, that little small nuance could be very beneficial in terms of the amount of time and the length with regards to visualizations. And I'm intentionally making these 2 videos shorter than usual, or at least I'm trying. Because in the visualizations, I want to start from scratch and layer each piece on so that we can discuss the finer details. And if it comes out to be 2 videos, I'm sorry. I'm so sorry, but it's worth it so that we can really hone in on that skill set of learning by doing, of course, but also learning each and every layer and what each and every layer does following ETV Cycle 5. All right, well, thank you so much for your time, and I look forward to talking to you in the next video.